All right, Common Core Geo kids, in this video I'm going to do the information that I didn't want to put in the last video because I didn't want it too long on spheres, and then we're going to be doing something called Cavaliere's principle and the density function. Okay? All right, so starting off, we have volume of a sphere. Okay, so you're going to be giving the formula. Volume is 4/3 pi r cubed. That's simple. So you'll have some sphere. They'll tell you, okay, the radius is, say, 5. So the volume would be 4/3 pi times 125, which would just be 500 over 3 pi, say, centimeters cubed. Okay, that's the volume of a sphere. Now, if they give you a hemisphere, they're not going to give you this formula, but the question comes up often. Volume of a hemisphere is just half of that. So it's 1/2 4/3 pi r cubed, or 4/6 pi r cubed, which is the same as 2/3 pi r cubed. All right, so for this question, we would have 2/3 pi times r cubed, which is 5 cubed, 125. So this would just be 250 pi over 3, which makes sense because it's half. A hemisphere is half of a sphere. So a hemisphere, you're talking about something like this, okay? The top part. That is what a hemisphere looks like. Then if they do ask you surface area of a sphere, okay, that formula is surface area equals 4 pi r squared. So the surface area of this sphere is just 4 pi times 50, or 200 pi. The units would just be centimeters squared, though, because it's area. Excuse me. All right. In this question on the bottom, you have, this was a Regents question. They're saying that Sue believes that these two cylinders from the August 2017 New York Regents have the same volumes. Is she correct? Explain why. Most of the prisms are going to be right, okay? This is a right circular cylinder. This is oblique. It just means the angle's different. This is an oblique cylinder. It doesn't matter whether it's right, standing up straight, or whether it's slanted. It's going to be the same volume, okay? Because volume, remember, is pi r squared. Well, let's go back to base area. It's the base area times the height. Base area times the height. But the base area for both of these are pi r squared. The height for both of these are 11.5. Okay, and it ends up that the radius is the same in both of these. So we'd have pi times 25 times 11.5. And then over here we'd have pi times 25 times 11.5. You don't have to go further. These are equal. So is Sue correct? Yes, because the base areas and heights are equal. Okay, therefore, the volumes are equal. Okay, that's really it. You don't really need to know the word anymore. Cavaliere's principle. If you did, you could use it. You could say that the volumes are equivalent based on Cavalier's principle. But Cavalier's principle was taken out of the curriculum, so out of the Common Core curriculum. But it's not going to hurt you to know it. Okay, let's take a look at a problem that has to do with density. Okay, so here, I'm going to highlight the important information. We have a snow cone. It is filled with shaved ice and topped with a hemisphere of shaved ice. Okay, so you have, it's filled, okay, and it's filled, that's a cone. And then you have a hemisphere on top of it. The inside diameter of both is 8.3, so that's your diameter. The height is 10.2. All right, so in the next part of the problem, they're telling us that the desired density, so this is the density of the shaved ice. I like to just highlight the important information. And the cost per kilogram, so this is a unit rate, cost per kilogram is $3.83. Okay, determine and state the cost needed to make 50 snow cones. So there's multiple steps here, right? You have to start off by getting the volume, number one. So we have volume is going to be the cone plus the hemisphere. Okay, the cone's formula is 1/3 pi r squared h. The hemisphere is going to be, remember, 2/3 from the previous page, pi r cubed. So this will be 1/3 pi. Okay, r is going to be 8.3 divided by 2 squared times 10.2 plus 2/3 pi, and we have r 8.3 divided by 2 cubed. Okay, I'm going to stop, pause the video, and I'm going to type this into my calculator directly, exactly how it appears in front of you. And I will just round to the thousands place for now. All right, so I typed it in exactly how it appears using alpha y equals, okay? If you type it in exactly how it is, you're going to get 333.654. And these are centimeters cubed. Now, it says the density, right? And then they're talking about cost per kilogram. So we need to get kilograms. So first we're going to get grams. So I do what's called unit analysis. I have this conversion. That's the desired density. I have this amount. I want grams. So that means I want centimeters to cancel out. So that means I'm going to multiply. Okay? So there's a formula, density equals mass divided by volume. And what I'm doing here is I'm getting the mass. I'm saying mass is density times volume, right? Or volume times density. So I have my mass is going to be 0.697 grams per centimeter cubed times 333.654. I highly suggest that you do this unit analysis. You want the units to cancel out. Okay, let me pause and type this into my calculator to multiply this. You should as well. All right, so I got 232.5568, etc. Okay, this is grams. Now, do you remember King Henry's dead uncle drank chocolate milk? I need to convert this into kilograms. So when you have grams and you're converting to kilograms, you have to move your decimal to the left 1, 2, 3 places. Okay, think about it. Kilograms is a larger unit, so you're going to have less of that thing. So this is 0.2325568 kilograms. Larger unit, smaller number. Makes sense. So move the decimal left because you're going from grams to kilograms. At any rate, then it says the cost per kilogram of ice is $3.83. So it's $3.83 per kilogram. So you want the cost of 50 cones. So we're going to have 50 cones times $3.83 per kilogram times 0.2325568, right, kilograms. So this crosses out, and then you just end up with a decimal number. Okay, so let me pause that and type that in, and we're going to round to the nearest hundredth because we're dealing with money. So the cost is $44.53. So this is what happens in Common Core geometry in 10th grade math, is you're going to have problem solving. Just like when we did trigonometry and then we had the 3 triangles in the picture and I taught you the law of sines, okay? These are also level 5 problems. Okay, let's take the last question. So this was also on a Regents. You have this model, okay, that is representing this water tower. And then they give you these numbers. Okay, first we have to get the actual volume of water, right? So we need to determine and state to the nearest cubic foot. The volume of the water tower. Okay, so that is made up. The volume is made up of a cone at the top plus a cylinder in the middle plus a hemisphere. So let me write all these formulas. 1/3 pi r squared h, cylinder pi r squared h. Now you can write, b times h, 1/3 b times h, and then substitute in, but you may have the formulas memorized by now. Hemisphere from the previous 2 slides, 2/3 pi r cubed. Okay, so we have the radius. That's not a problem. We have this height. We need this height. So we have to start by using trigonometry right over here, right triangle trig. So I have the 47. And half of, so this 8.5, let me just see. The 8.5 is from A to C. Okay, so that goes here as well. That's half. And we're looking for this side here. I'll call X. So you're going to start off by doing tangent. 47 is X over 8.5. Okay, so X, the height. Now, you can type it in, but we really don't have to. I can just go like this, 1/3 pi r squared times my height. My height, I just my cross product here. 8.5 times tangent of 47 plus pi times r squared times the height of the cylinder, which is 25. And then we have the hemisphere, 2/3 pi r cubed. So I want to get this to the nearest cubic foot. Okay, so I'm going to pause the video and type this in. Make sure you're in degree mode, okay? You should do the same. Type it in, make sure you get the same answer. All right, so the answer on my calculator, I'm just going to write it out first. 6880.637174. Okay, so to the nearest cubic foot, this is about 1 cubic feet. Okay, then it says the water tower was constructed to hold a maximum of 400,000. So this is called a constraint, by the way. So maximum of 400,000 pounds of water. Okay, then water weighs 62.4 pounds per cubic foot. Can the water tower be filled to 85% of its volume and not exceed the weight limit? All right, so number one, I'm going to convert this 6881 feet, right, which I'll just use the 6880, etc. I'm going to convert that into pounds, okay? So I have 62.4 pounds per cubic foot. So you can see by unit analysis that we want feet cubed to cancel here. I want these to cancel. Okay, so basically I'm getting the mass like in the last problem. Okay, this weight functions the same as density. So anyway, when I multiply this, I want to multiply this then by 85%, right? So I want to know, is 4,000, how does that work with this 85%? So 85% times all of this. I need to compare this to the 4,000 to make sure it's not over. This cannot be greater than 4,000. So I'm comparing this, 400,000. All right? This cannot exceed the weight limit. Cannot exceed. No, right? So it has to be less than or equal to it. All right, so you just type it in, kids. And there's many different ways of doing this. I just like to type things into my calculator doing the least amount of work, okay? Because I like to be efficient. And anyway, I already have this number on my calculator, so I can just capture it off. So into my calculator, I'm typing 0.85 times 62.4 times this number, right? And so I get 364,948.9957, which is less than 400,000. So justify your answer. Justifying your answer is showing you work, so we're good. All right, those are typical Regents questions, guys. You could see why it's completely different than middle school, because you're applying it to density, and you're doing a lot more with it as well. Okay, thanks. See you in class.